Hello students, today we are going to learn about a multi-programming. Multi-programming is a parallel processing in which the multiple programs can run simultaneously. A multi-programming is the allocation of more than one concurrent program on a computer system and its resources. Multi-programming allows using the CPU effectively by allowing various users to use the CPU and input-output devices effectively. Multi-programming makes sure that the CPU always has something to execute, thus increases the CPU utilization. Next topic we are going to learn, that is process and different process states. So now, what do you mean by a process? A process is a program in execution. Process is not as same as program code, but a lot more than it. A process is an active entity as opposed to program, which is considered to be a passive entity. Attributes held by process include hardware state, memory, CPU, etc. Now, this process memory is divided into 4 sections for efficient working. The text section. The text section is made up of the compiled program code, reading from non-volatile storage when the program is launched. Now the next is data section. The data section is made up the global and statistic variables allocated and initialized prior to executing the main. Now the heap. The heap is used for the dynamic memory allocation and is managed via calls to new, delete, free and etc. The stack is used for local variables. Space on the stack is reserved for local variables when they are declared. Now, different process states. Processes in the operating system can be in any of the following states. New. The process is being created. Ready. The process is waiting to be assigned to a processor. Running. Instructions are being executed. Waiting. The process is waiting for some event to occur, such as an input-output completion or reception of a signal. Terminated. The process has finished execution. Now, process control block. There is a process control block for each process enclosing all the information about the process. It is a data structure which contains the following. Process state. It can be running, waiting, etc. Process ID and the parent process ID. CPU registers and program counter. Program counter holds the address of the next instruction to be executed for that process. CPU scheduling information such as priority information and pointers to scheduling. Memory management information, for example, page tables or segment tables. Accounting information, the user and kernel CPU time consumed, account numbers, limits, etc. Input-output status information, devices allocated, open file tables, etc. Now, what do you mean by a purchased priority? In this priority, higher priorities processes are charged at a higher rate. The operating system keeps the track of the time used by each process and charges it accordingly. Now, internal priority. It is decided by scheduling algorithms. Their calculations are based on the current state of the process. Now, what are the advantages of priority scheduling? The priority of process is selected on the basis of memory requirement, user preference, or the requirement of time. Processes are executed on the basis of priority. So, higher priority does not need to wait for long, which saves time. It is easy to use. It is a user-friendly algorithm, simple to understand. It has reasonable support for priority. The major disadvantages of priority scheduling is the process of indefinite blocking or starvation. This problem appears when a process is ready to be executed, but it has to wait for the long time for execution by CPU because other higher priority processes are executed by the CPU. Now, what do you mean by a segmentation in operating system? A process is divided into segments. That program is divided into which are not necessarily all of the same sizes are called segments. Segmentation gives users view of the process which paying does not give. Here, the user's view is mapped to a physical memory. There are types of segmentation: virtual memory segmentation and simple segmentation. So now, what do you mean by a virtual memory segmentation? Here, each process is divided into a number of segments, not all of which are resident at any one point in time. Now, simple segmentation. Each process is divided into a number of segments, all of which are loaded into memory at runtime, though not necessarily. There is no simple relationship between logical addresses and physical addresses in segmentation. A table stores the information about all such segments and is called a segment table. Now, segment table, it maps two-dimensional logical addresses into one-dimensional physical addresses. Base address, it contains the starting physical address where the segments reside in memory. Limit, it specifies the length of the segment. Translation of two-dimensional logical address to one-dimensional physical address. Segment numbers, number of bits required to represent the segment. Segment offset, number of bits required to represent the size of segment. Now, what are the advantages of segmentation? No internal fragmentation. Segment table consumes less space in comparison to page table in paging. Now, disadvantages of segmentation. Our processes are loaded and removed from the memory. The free memory space is broken into little pieces, causing an external fragmentation.